Well, wouldn't it be nice if you could take an OSDP-enabled reader and connect it to an existing Wiegand control panel? That's what the Osm-Cpi module does for us. Its whole purpose is to be that one-size-fits-all interface so that you can connect any OSDP reader, which would eliminate some of the vulnerabilities that we're well aware of by having Wiegand wires on the attack side of a door or gate. This module will take the 4-wire OSDP signals, so that's the power, and then the RS-485 or twisted pair. And then it breaks it out into roughly the equivalent discrete signals. So the Wiegand, the LEDs, beeper, etc., all done so that you can connect it to a panel. All right, to demonstrate the functionality of the Osm-Cpi, we have 2 readers. One is a Wiegand reader, and we have it wired up in the traditional power, data 1, data 0, and LED signals. So if I were to plug that into a typical access control panel, flip it around there, and if I present a badge, I get the green light from the access control panel to indicate access granted. So again, sent that. The LED signal is brought to 0 volts, which is interpreted as a change of state on the LED. Now using an OSDP enabled reader, we would have our twisted pair going whatever length, 4,000 feet if you need it, and power. So those 4 wires connect into the Osm-Cpi control panel interface. And we've broken out the appropriate wires to go to the same connector as you would the Wiegand reader. So power ground, data 1, data 0, and the LED. So if we plug that into our control panel, get the same boot up sequence. As you see, the LED is flashing, which indicates that it's communicating over the RS-485 to the reader. And if we present the badge, we get the same indication as we do on the Wiegand reader. The LED changes state. So what's happening is the LED signal is being brought to 0 volts, just as if it were a Wiegand reader. But the CPI is interpreting that discrete signal and executing or sending the appropriate LED commands to the reader. And do it again, it sends the LED on, and then it sends the LED off. One of the best features of OSDP is adding the secure channel protocol, which means that the reader and the access control panel would typically have secure keys that would encrypt and authenticate the packets going over the twisted pair. The CPI is designed to control one reader, so it's meant as a retrofit. So you can quickly take a OSDP reader, connect it to a legacy panel, and not have to do much else in the way of configuration. Except if you want to use the secure channel, then these extra wires are configuration wires. So you can ground a couple of them and power it up, and that tells the CPI to go into what's called pairing mode. So it will generate its own unique random key, send it across to the reader. They'll have a key exchange, and from then on, those two are paired. So the encryption keys are unknown to anyone outside, just the reader and the CPI, and because of the way they're designed, there's no way to get to those keys at all. You can't get to it from the outside. One other feature is we're demonstrating this on a 1-wire LED controller. If you have 2 LEDs and you want one color for access granted and another color for access denied, also by way of the configuration options, you can tell the CPI to interpret those signals and send the appropriate commands as well.